Hi, welcome to educators.com. I'm Shravanti, your Hadoop instructor. In this module, we are going to discuss about the MapReduce performance tuning techniques. To improve the performance, you can use the combiners. So the combiners are nothing but it works like your mini reducers. That means when you submit your job for the MapReduce, whatever the intermediate mapper output results are there, instead of sending each and every intermediate mapper output results to the reducers in between the shuffle and the sort phase, what we have is we can place a combiner by simply setting up the job.setCombiner class in the driver class. So what it does is, whatever the code you are executing, you can execute the same reducer code at the each mapper level. So it obviously reduces the network bandwidth whenever you use the combiners. In the previous modules, we have clearly discussed about how to work with the combiners, what scenarios we can set these combiners, and how to implement them as well. And another technique what you can use to improve the performance is the compression, because whatever the mapper output results we are getting, those are the very large results which we are getting it. So usually when you do a compression, it may be, just forget about the MapReduce now. So sometime, let's assume I have a file. If I zip it, obviously the size of the file is going to be reduced. In the similar way, if I use the compression techniques for the MapReduce, whatever the mapper output results are there, that means intermediate mapper output results, those are going to be compressed and it reduces the size of the intermediate data. So how you can set it up, this thing is nothing but mapred.compress.map.output, the parameter which you can set it up. And also here we do have all other compression techniques are available, like ZZip, LZO, Snippy codec. A lot of compression techniques are available. You can use any of the compression techniques to improve the performance over here. And also, to improve the MapReduce performance, you can fine-tune your number of mapper and the reducer tasks as well. That means, let's assume that I have a 1 terabyte of the file. By default, block size is the 128. So if I have the 128 MB, I'm going to get approximately 8,000 mappers are going to be created for the 1 terabyte of the file. That means 1 terabyte by 128 MB, which leads to the 8,000 mappers. So let's assume if you are having all the bigger files, instead of giving the small data set, instead of giving the, so here to initialize all the 8,000 mappers, it will take time as well. And also here what we can do is, in that cases, you can even change the block size to the 256 or the 512 MB as well. So according to your input file, you can even fine tune your number of mappers and also the reducer tasks. So when it comes to the reducer task, by default, the reducer task is only one. If you want to have this more parallel tasks for the reducer too, to improve the performance, you can even set with the help of job.set number of reducer tasks to the parameters, to the parameter whatever the value. If you set it as a 5 reducer tasks are going to be created. Like that, you have to tune your mappers and also the reducer tasks as well. And the next technique what you can do is the JVM reuse. That means, usually if you are having a smaller task, that means a Uber task, which we call it as. So if whenever you are having such kind of the smaller task, instead of creating a new JVM, what we can do is you can simply reuse the existing JVM. How to use the existing JVM is nothing but the parameter. We can set it up in terms of the mapred site.xml or yarn site.xml. You can see this mapred.job.reuse JVM number of tasks. You can set this particular parameter as well. And also we have another parameters. These are for the adjusting the spill records and the buffer size. What exactly this means is whenever you execute your MapReduce job, you will be getting a lot of intermediate mapper output results. These results are temporarily going to be stored on the disk. So whatever the disk it is storing, store it from the memory to the disk. That means we call it as a disk space. And also here we have a sort, it must need to be sorting to be performed there itself. So to control your disk spills and also this sorting, we have a parameter called io.sort.mb. By default, this value is set to the 100 MB. So what exactly this io.sort.mb means? Whatever the value you are setting here, that is the amount of the buffer memory. That is the buffer size, 100 MB is the buffer size is going to be used to sort your files. Similar way, we have the io.sort.factor. That value is by default 10. So this value takes care about how many number of streams you are merging at a time. So even whenever you are dealing with a huge amount of the file sets, you can even modify this particular parameters io.sort.mbs and io.sort.factor parameters according to your need. And another thing which you need to remember for the performance tuning is using the appropriate data type for our data. For example, if we are working on some non-textual data, that is some integers or the float, make sure that instead of using the text, because text we can use it for any of these numeric data or anything, and we can even use our methods to convert the text data into the integers afterwards. But instead of writing that, whenever there is a need, if you are working on the int writables, float writables, such kind of the things, you can directly use such writables instead of using the text. There is another technique called speculative execution. Speculative execution means if you have a cluster, Hadoop cluster, in case one of the map tasks or any of the one of the map or reducer task is slow when it compares with the other tasks in the system. So it's automatically the system will be understanding that one of the tasks is very slow. So what it does is it will instantiate the same task into the different machine, because your system assumes that the machine, that particular task is slow. That is the reason why it will instantiate the task in another machine. So which one will be considered is nothing but whichever task finishes faster, it may be a older one or the newer one, that will be taken into the consideration. The rest of the one will be killed. Usually this speculative execution is to improve the performance. But in a larger clusters, what it is going to happen here is if the speculative execution is enabled, unnecessarily it will instantiate the separate tasks. So that will take a lot of time to execute the bigger tasks. So to avoid this, what you can do is you can disable the speculative execution by changing the mapred.maptask.speculative execution or mapred.produce.task.speculative execution to false in your mapred site.xml file. And also we have another technique called the distributed cache. You can use this to improve the performance. Whatever the small files you are having it, instead of storing as part of your single disk, what we will be doing here is all the data nodes, main memory, we will be storing this particular file. So instead of doing this disk reads and writes, it automatically reads it from the main memory. So the performance will be automatically improved when you use the distributed cache mechanism. So in the previous module, I have clearly shown you how to use this distributed cache and how to store your file in the cache by simply setting up the job.addCache file in the driver class and the context.getCache files to read the cache file details. And there are another number of ways to set it up. These are the basic things what we will be doing it in our projects. Summary. We use the combiners to reduce the network flow to improve the performance, and we can fine-tune the number of mapper tasks and the number of the reducer tasks. But also we can fine-tune the disk size, block size as well. Whenever it is required, we can also use the compression techniques to improve the performance for the intermediate data size to reduce. We can also reuse the JVMs, and we can adjust the parameters of io.sort.nbs sort.factors for the disk spills. And we can disable the speculative execution for the bigger clusters to improve the performance. And we can also use the distributed cache mechanism to store the files as part of your main memory.